In first grade, students start to make their first jumps in dealing with some larger ranges of addition and subtraction. And this is where we can start to expand the reasoning strategies that students can use to sort of manipulate and change numbers and think flexibly with numbers as they add and subtract with larger ranges of numbers. And that first increase happens where students move from, in kindergarten, formerly only adding and subtracting within 10, to in first grade, there's an expectation of procedural reliability, adding and subtracting within 20. Now, we're going to use some of those skills that we worked on in kindergarten and utilize them in a way that allows us to be procedurally reliable as we add and subtract within those numbers, sums within 20 and subtraction within 20 as well. Two of those really important skills, the first of which is that addition within 10, that sort of single digit addition, being very fluent within 10. Another one of those skills from kindergarten that students would have began working on is the idea of pairs that make 10. Knowing 8 and 2 make 10, 4 and 6 make 10, 3 and 7, 7 and 3. All of the pairs of numbers, any number from 1 to 9, what number we pair with that to make 10. That's one of those kindergarten benchmarks, and we're going to leverage that skill, these strategies in first grade. And then the final piece that's going to be really helpful is also knowing how to sort of decompose numbers 11 through 19 into tens and some ones. So knowing that 12 is 10 and 2, 18 is 10 and 8. So those skills are going to kind of come together. We're going to get to practice and use those skills and apply them into some thinking so that we can add and subtract and reason with that addition and subtraction of numbers, of expressions that live within that range of 20 that students will start to work with in first grade. So we've got two strategies we're going to talk about. The first one, this make 10 strategy. This is going to be for addition. And then we have the get to 10 strategy that we're going to use to think about subtraction. So with this strategy, I sort of like the names of them like this because they're sort of self-explanatory. They tell us what we're doing, but they're also mathematical in nature. So they inform us in a way that actually informs our mathematical thinking. So to show these strategies, to visualize these strategies, I'm going to use a tool, a model called an open number line. In kindergarten, students worked with number lines that have all of the numbers sort of marked in between them. We see all of the hash marks kind of working up, and we have all of the numbers shown. It's sort of a closed number line. We have these fixed points on the number line. Everything is proportional and related to each other. And we can use this number line in kindergarten to show the idea of counting up and counting back for addition and subtraction. 2 plus 3 we can see as 2, and we count up 3 spaces to land at 5. That's a closed number line that gets used in kindergarten. A way that we can expand on this tool in first grade as we start to work with larger ranges of numbers, dealing within 20, and then later in first grade we deal with numbers up to 100, we use a tool called an open number line. And this open number line allows us to not necessarily have to write every space in between. We just put the numbers that we need, and we use the tool of the number line to help us have sort of a relationship of moving up, moving back, and counting back. It helps us to visualize our thinking as we count up, as we count back, but we can make our jumps more flexible, and we can visualize it in a way that's a little more efficient with this open number line. So I'll jump right in with this first example, 9 plus 6. What we want to do for this strategy is we're going to pick one of the numbers we're going to start with. And for this make 10 strategy, I typically like to pick the number that's closest to 10 because I'm going to have to make a smaller jump at first. So I'm going to think about starting with 9. Now with this make 10 strategy, the first thing that I want to do is make 10. And I know that if I add 1, I'm going to make 10. All right, now in this example, we kind of have it looks a bit like a closed number line that we're sort of building because we did just jump 1. We went from 9 to 10, but I didn't need the number line completed at first. I'm just using the number line to show the thinking that I'm doing as I get there. So I make that jump of 1, I move to the right 1, and that gets me to 10. This is where that benchmark in kindergarten, that understanding of pairs of numbers that makes 10, knowing that 1 is that number we pair with 9 to make 10, is really, really beneficial. So I made my 10 here. But I'm supposed to be adding 6, not adding 1. So now I have to think, well, I added 1. How much more do I need to add so that I can add the 6? And here's where knowing those smaller addition facts sort of within 10 can help. And so a student might know that, well, if I'm supposed to add 6, that means I need to add a total of 6. I've added 1. Well, 1 and 5 make 6. So I need to add 5 more. And with the open number line, instead of drawing everything in between, I'm just going to show that big jump of 5 and then write down where I end up. Now, getting to that 5 at first, students might not be as fluent with that. Those lower digits of automaticity of addition within 10 might still be developing in students. And so if they need to think, well, I added 1, how much more do I need to add? 1, 2, 3, 4, 5, 6. If they have to use their fingers to figure out that 5, it's okay. That efficiency will come over time, but if we start this reasoning early, when that efficiency does eventually build, they can already reason like this, and that'll just make them that much more efficient and that much more fluent of mathematicians as they're working on problems like this. So we add our 5 so that we have a total of adding 6 because that's what we're supposed to add. And now here's where we see that idea of 10 and 1s, what number that makes comes into play, that benchmark from kindergarten. So 10 and 5 make 15, so 9 plus 6 is 15. All right, and again, that idea again, that make 10, our first step is we want to make 10 using that knowledge of pairs of numbers that make 10, and then we add whatever's left, but we're just adding those 1s to a 10, and we know 10 and some 1s, what that number is going to be. So let's see that example. Again, another example of the make 10 with addition strategy. So this one, 8 plus 5. I'm going to start with 8. It's a little closer to 10. If I'm trying to make 10, that's a smaller jump. So I'm going to start with 8, and I know that 8 and 2 make 10. So I'm going to make a jump of 2, and that's going to put me at 10. But I'm supposed to be adding 5. So I have to think, if I added 2, what's left? Well, I know that 2 and 3 make 5. So if I add 3 more, that's going to put me at adding a total of 5. So now we just think, what is 10 and 3 more? 10 and 3 is 13. All right, so subtraction. So we can use a sort of version of this strategy, the same type of reasoning, to also answer subtraction problems, to find the difference to subtraction. We're just doing this whole process in reverse. We're going to use the same skills, the same reasoning, the same thinking, the same tool. We're going to use the open number line to model that. However, we just have to do some of the thinking, really all of the thinking, in reverse. So now instead of starting on the left and working to the right, I'm going to start on the right and work to the left, because now we're removing, we're jumping backwards, counting backwards, and so we'll start with 14. And the first thing that I want to do, as the name of the strategy suggests, is I want to get to 10. That's my goal. I want to get to 10 because working from 10 is a lot easier, a lot more friendly than working from 14. So I just have to think, how do I get from 14 to 10? And here we see that idea of knowing 10 and some 1s, what number that makes. That helps us. 10 and what gives us 14? Well, we know that 10 and 4 gives us 14. So now we've removed 4. But we're supposed to be removing 7. So we ask a similar question that we asked when we were adding with the make 10 strategy is, well, 4 and what would give us that 7? I know 4 and 3 more is 7. 4 plus 3 is 7. So if I remove 3 more, then I will have removed my total of 7. And then now we're using that pairs to 10 thinking. 3 and what is going to give me 10? I know 3 and 7 give me 10. So if I remove 3 from 10, I should be at 7. And so my difference is 7. For the last one here, one more example of that get to 10 strategy for subtraction within 20. Again, I'm going to start on the right and work to the left because I'm removing. Begin with 17, and again, that first goal is let's get to 10. How do I get to 10 from 17? I remove 7. So once I remove 7, now I'm at 10. I just have to think, I'm supposed to be removing 9, so how much is left? Well, if I remove 2 more, now I have removed a total of 9. 7 and the 2 means I've removed 9. I'm going back 2 from 10, so I'm using that pairs to 10. 2 and what number give me 10? 2 and 8 give me 10. So I know 17 minus 9 is 8. So hopefully you can see some of the connections between this make 10 and get to 10 strategy. They're really the same thinking. They're the same reasoning. That's why we can model them here on this same tool. One, we're just sort of building up, making 10 and continuing on for addition. And one, we're working back. We're getting to 10 and then continuing on to find the difference to subtraction. So as again, in first grade, students make that first jump moving from adding and subtracting within 10 to adding and subtracting within 20. We can start to use this strategy to build their reasoning abilities in first grade.